Candidates, in today's lesson, we are going to build an understanding on applying different circle theorems to solve for angles in circles. Before we start looking on theorems, we need to have an understanding on the different parts of a circle. The radius is a line which passes from the center to the circumference, and the diameter is the longest chord which passes from the circumference through the center and touching the circumference again. And the chord is a line joining 2 points on circumference but isingapfuuri nepacenter. An arc is a part of the circumference which is between 2 points, and a sector is a pi-slice region bounded by 2 radii and an arc. And lastly, a segment is a region between a chord and its arc. Tiratanga theorem 1, the angle at the center of a circle is twice the angle at the circumference subtended by the same arc. Tine circle redu with the center O and points A, B, and P on its circumference. Parikufomwa two triangles sharing the same arc AB, and the angle APB is twice angle AOB. If angle APB was to be at 35 degrees, angle AOB would be twice that at 70 degrees. For theorem 2, tikutarisa angles in the same segment. Angles in the same segment of a circle that are subtended by the same chord are always equal. Per circle radius, we have points A, B, P, and Q on the circumference of our circle and a chord AB. The angles APB is equal to angle AQB because they are both in the major segment above chord AB. So if we set angle APB at 40 degrees, that means angle AQB is also 40 degrees because are in the same segment. For theorem 3, tikutarisa angles in a semicircle. Angles inscribed in a semicircle is always a right angle triangle. Tine circle redu with the center O and points APB on its circumference. AB is the diameter, that means angle APB is at 90 degrees. This is because theorem 1 note angle at the center is twice the angle at the circumference, with the diameter AB per center pedupane 180 degrees, and half of that gives 90 degrees at angle P. Theorem 4, we are looking on cyclic quadrilaterals. Tirikuti, in a cyclic quadrilateral, when all 4 vertices lie on a circle, the opposite angles add up to 180 degrees. They are said to be what? To be supplementary. Meaning angle A plus angle C not per 180 degrees, and also angle B plus angle D are not per 180 degrees because they were all opposite angles. If we set angle A at 110 degrees, to find angle C we have to say 180 degrees minus 110 to get angle C at 70 degrees. And for angle D, we'll say 180 degrees minus 75 to D at 105 degrees. For the second example, we are given ABCD to be a cyclic quadrilateral, and angle DAB is at 95 degrees. So our task is to find angle BCD. So we know that angle DAB plus BCD equals to 180 degrees because they are opposite angles in a cyclic quadrilateral. So we'll say 95 plus x is equals to 180, and we make x the subject to x are 85 degrees. For our third example, takapewa AB as the diameter and angle CAB is at 30 degrees. We need to find angle ACB and angle ABC. So ACB and that is at 90 degrees because angles in a semicircle from theorem 3. Then for our last angle, we know that angles inside a triangle add up to 180 degrees. So we are going to add up all our triangles and equate them to 180 degrees. We make angle ABC the subject, and we find angle ABC at what? At 52 degrees. Summarizing on today's lesson, we've learned on different parts of a circle. Tikabata theorem 1, which says the angle at the center is twice the angle at the circumference. And for theorem 2, the angles in the same segment are equal. For the third theorem, we looked at angles in a semicircle. The fourth one, angles in a cyclic quadrilateral sum up to 180 degrees. And our theorem 5, we found out AB, when AB is equal to CD, angle AOB is also equal to angle COD. So on our next lesson, tichangeta ku solve our questions from ZIMSEC past papers. I will see you on that one.